Hey, good afternoon, everybody. We're back again. Alrighty, so what we have here on the workbench today is a 1x4. I'm going to kind of go through this with you guys a little bit, and kind of show you, explain some of what I've done and everything else. But yeah, we've had a lot of things here going on the last couple of weeks, and still trying to get everything caught up. Still behind. For the most part, I've quit taking stuff back in November. I've let a few things come in here and there, but like I said, I've still got a lot that we got to get completely caught up yet on. But I figured I wanted to take a little bit of time today and kind of talk about this one here. Show you some of what we've done to it, then go through, hook it up, and show you what the final results are. Good afternoon. Good afternoon, Shell. This one, big guy, is one that's coming from your neck of the woods. You may recognize it. But anyhow, this one has kind of fought me a little bit, and we wanted to kind of walk everybody through this, for a couple of different reasons. Let me get the camera up here, maybe where you guys can get a real good view here. Let's talk about this stuff right here first. Current and voltage ratings and stuff like that. All right. Well, this is supposed to be 8-gauge wire, which it is. I ought to recognize that one, but I couldn't tell you who you are off the top. Oh, Art. That takes a minute. Anyways, what we've got, like I said, is a 1x4, and we're going to start with the power wires. And the reason why, I'm trying to get as much of this into the camera view as I can for you guys. On this, like I said, we're going to kind of start backwards and go through things, but where was it at? Right here. Mainly because the rest of it's all wore off. But the identification, if I can get it in there. Right here, CCA. All right, so what this is copper clad aluminum wire, which it does work for some things. I didn't like how some of the wire was soldered in there, and I thought, well, let's go ahead and move that. I didn't think much about it being light in my hands whenever I sit there and picked it up. But one of the things that copper clad has been out for a while, and the reason why is because of the cost of copper, obviously. Now, copper clad, what that is referring to is it's copper clad aluminum. So this is actually aluminum wire. This is not even copper. Although it's tinned with copper, it's not, regular copper. So once you go beyond what they call the skin depth, then you start pulling or drawing the current directly off of the aluminum. Now, aluminum is still a decent conductor. However, whenever you're pulling quite a bit of current off of this wire, you're going to start dropping some severe amount of voltage. Although it can handle a lot of different ratings and power, for something like a 1x4, an 8-gauge with copper clad, it's just not going to happen, guys. You're going to drop a lot of voltage. I actually seen, because these are about 2 feet in length, and I was seeing almost 2 volts of voltage loss on the inside of this amplifier. Before I actually changed these out. So this got changed out. What we did was we pulled these out. Normally, whenever I build, I usually use 2 8-gauge. I did go ahead and stick back with just the single, but I upgraded to the Stinger wire. Now what's nice about this is a tinned copper. It's solid copper, but it's got a tin coating on it. And that tin coating actually helps, number one, it promotes good soldering, for number one. Number two, you're able to actually draw through the entire skin depth of the copper and get the amperage that's needed. So, Mr. 425, we're doing pretty good. So, copper clad aluminum, it can be used for a lot of different things, even in the world of the RF that we deal in. But this thing really should have had probably about 3 of these, just because of the aluminum. So that was one of the problems that I'd seen with the amplifier that got changed out. Multiple different things. Go through here and show you out of our little goodie bag here. Get down here. So had several burned up resistors on the input and on the output, as far as on the combiners. So those have been replaced. It also had on the feedback resistors on the opposite side that was the main problem. You'll actually see there's a little bit of heat check where they were trying to do all the work as far as the other two before everything finally let loose. So that's all been taken care of. The output tuner had actually fallen out, which I've got a few of these which I'll use like on a 2-pill or something like that. Although they're heavy enough rated, the problem with them is that they are so old that once they're put under stress on an output tune, they just don't seem to hold up. So we went ahead and replaced the output tuning capacitor. But now, one of the really unique things was on this amplifier. It had, dig through here and find the other one. It's in here. Yeah. May have gotten thrown in the actual trash too. Okay, so anyways, these are not resistors. These are actually chokes. And this was what was on the output of the 4-pill. Here's where we're going to start talking about ratings. Now, these little chokes that are almost the size of a 1/2 watt resistor, these are actually only rated for about 100 milliamps. Okay, this is okay for a 1-pill, but when you go into a 2-pill or a 4-pill configuration, one of the problems that you wind up with, part of that has to do with the ease, because the chokes are already made for you. That's one of the nice things about these. However, the worst thing about these is the fact that these are only rated for about 100 milliamps for your Class C choke. Now, what you get into whenever you're dealing with those chokes like that is those chokes, whenever you're going off of your Class C to ground, believe it or not, there's about 256 milliamps of current draw that goes across that choke. So whenever you're dealing with, well, hello, Mr. Hood. What's going on, buddy? So when you're dealing with your current draw and current ratings, for that portion of the circuit, like I said, you're dealing with a part that, this is, like I said, it's only rated for 100 milliamps. Okay, so we've got 2.5 times the current draw that has to go through this. Okay, well, one of these had failed. There's multiple different things that's happened to this amplifier. I know it's been repaired at least one at a time since its original build. But, whether they caught it or not, one of these somewhere in, like I said, somewhere in all this mess, which there was 3 of them in there, I've replaced all 3 of them. Now, I did use a factory choke on the 1-pill. which is right here. Okay, but now this particular choke is rated for 1 amp. So it can handle up to 1 amp of current draw off of it. Now granted, that's overkill for the 1 pill, because there again, you're only looking at, on a 2 pill section, about 250 milliamps. So basically a quarter of an amp. So that's got 3 times the rated power. Now you go into the larger chokes like this that everybody uses, whether it be on a 1/4 inch ferrite or a 1/2 inch ferrite. Typically if you're using like a number 20 or 22 gauge wire, they're actually rated for about 6 to 8 amps, with that small wire. No, that's not one of Early's. I don't know. I haven't. I tried calling him earlier today, and he didn't answer. So I'm figuring he's still under the weather. Figured he might pop in for a visit here on the on this, but there again, I don't know, because he's had a lot of issues with his ears here lately. So he's probably not even hearing the notifications that's going on. So that was some of the different things that I wanted to talk about. Like I said, current rating. A lot of people think that that copper wire is copper wire, but like I said, they see the OFC, and that sounds great, but you really got to do your research. Going back to your wire, like I said, this is actually copper clad aluminum. Now, there are certain instances, like I said, where CCA is okay, but not when you're trying to draw 60, 70 amps off of off of this. It's just not capable of it. I think this actually can only handle a continuous current of about 30 amps, because of the fact that it's clad aluminum instead of clad copper. So, be aware of what you're actually getting whenever you buy stuff. Like I said, that was one of the issues. One of the other problems that I've seen that we were having with this particular build was in the keying circuit, where they had doubled up the capacitance. It was drawing the radio way down. So we got rid of that, took care of that. Transistors. We've got 3 of them that were bad. The other one has an HFE rating of 11 on it, which I wrote down here off to the side. It's nearly shot. So that's another one of those that has gotten pulled out and gotten replaced. Now, what's kind of unique is two of the 4 resistors, or what a lot of us guys call tattletales, which are 10 ohm resistors. 2 of these actually got completely burned, so it was easy and obvious to tell, which section gave out first. Which also happened to be the side that our little 100 milliamp choke gave out on. So like I said, just a lot of little stuff that had caused some issues as far as on the overall with this. I don't know what actually started the waterfall, if it was high standing wave, or what the case was. Because there's just too many things that actually caused some issues. So we went ahead and pulled all that out. One of the other things that we did, now there's a great debate on this, and I'm kind of in the middle of it, which is right here, which is on your what they call a flyback resistor. It's not a feedback, but it's flyback. Now, oftentimes you'll see people use, I've seen anywhere from 22 ohms all the way down to about 2.2 ohms of resistance as far as across here. I actually use a 1 ohm resistor. It actually did have just a straight wire across there. The reason why I pulled the straight wire out, which is okay and has been accepted and used for many, many years too, the reason why I pulled that out and I put a 1 ohm resistor is essentially what it amounts to is, if I've got a fight between the 4-pill section and the 1-pill section. What this does is this allows me to take the FLIR, take a reading off of it, and see whether or not it's getting hot. If this is getting hot, that means that something between the input of the 4-pill and the 1-pill, it tells me that there's something fighting in between there. So that's part of the reason why I typically just use at least a 1 ohm resistor. Like I said, it's not much, but it's just enough to kind of give me an idea of what's going on in between the 2 sections. So we went ahead and replaced that as well. So we replaced all of our 10 ohm resistors on the output. We got that taken care of. We went ahead and checked all of our capacitors. Since the 120s were not soldered in between like most of us typically do and on the sides of the transformer, these were actually soldered off to the center, to ground, which is fine too. But we went ahead and took just a little extra time. We went ahead and checked those to make sure that those were still in spec, which they are. So we got that taken care of and squared away. Another thing on the output, the pass-through tune. The pass-through tune on this thing was horrible. We had about a 1.7 on the standing wave, so we went ahead and retuned the pass-through. Now we've got it down to about a 1.1. Mr. 114A, yes. And yours will be coming up one day this week too. Like I said, I've got the radio, so that's actually one of the things I'm going to try to work on and get started yet this evening, and working on yours. But yes, yours would be an ideal radio for this. Now, the way this amplifier, I think, was originally tuned, I think it was tuned for Bird and not for PEP. So whenever I hook this up here in just a little bit and show you guys, you're going to see more on the RMS than what you are on the peak. The peak wattage is low, but the Bird wattage is right there where it needs to be. So, we're going to go ahead and leave it the way it is, because, we're not reinventing the wheel. We're just doing a repair. Yep, I've already checked the output on that as well. So, like I said, all the tuning as far as on everything across here is all correct. That's good. This is about 5 puff less than what I typically use for my starting point. And I say starting because of the fact that oftentimes, you're going to change things just a little bit. So, that's actually pretty good as far as on that. Like I said, just a snowball effect. Different things. Like I said, I'm not sure the exact person that actually owns this, which is immaterial. But like I said, we went through everything. The biggest thing, like I said, that I seen as far as, well, not the biggest thing, but like I said, just a handful of a lot of little problems. So one of the things I'm going to do is I'm going to go ahead and show you guys. We've got a little 30-watt Telewave dummy load, and I use this thing religiously. And what I use this for is for my pass-through. Why? Because I can screw it right on here, right onto the antenna side. That muzzle down in there. Get a little jumper here. Now, we did retune the input, which was way off of the 2-pill. Like I said, just a lot of little stuff, guys. That was the thing that I seen was just, there wasn't one in particular thing that I can say caused the problem or didn't cause the problem, because there's just too many little things that, contributed to this. Part of it could have been, where it was starting for voltage. That could have been a lot of it. So, like I said, we went ahead and changed a lot of little stuff in this to go through it, so we're going to start here. What is that? So CCA is a high quality wire, huh? Well, it is to a certain degree. But, like I said, it has its limitations. Alright, so show you the pass-through going through it here. I think I'm going to have to replace this jumper. So right there we go. So we've got 1.0 on the standing wave going through it, 55 ohms, and I may have to replace this jumper even to finish out this. Okay, reactance of 0. So pretty good. Like I said, 53 to 54 on the resistance, reactance is 0, SWR is 1.0 on your pass through. And I'm going to tie a knot in this, throw it over in the corner, and I guess I get to make up some jumpers yet today. Or tomorrow morning. Probably tomorrow morning. That way we know it's got a problem in it. Alright, so. Let's get some of this stuff here out of the way. Yeah, I like using my little 3-foot jumper for a lot of things, especially working here on the bench for radios and what have you. Why? Because it's short and I don't have to deal with 6 feet of coax. Oh, one of the other things that we did too, that was not a part of the circuit, which is now, right here. We actually put a 10 amp diode as far as for short circuit protection, but it's not just for short circuit. It also helps in relationship to EMF as far as off of your alternator and things like that. Believe it or not, it actually helps to dissipate some of the different high frequencies along with your capacitors that's off there. Now, the other thing too that I wanted to make mention, since we're talking about wires, is right here on our incoming. Okay, they had, instead of having your main feed actually placed in between your two primaries, they were putting it all the way over here off to the one side. So this one over here, which is where most of the damage had occurred on this side, again, was starving for power. So, we went ahead and centered up our wire. That way we've got more of an equal spread and feed across to both of these main transformers. The one pill, because it doesn't draw that much current, it's the reason why all of us typically just tack it over to the one side. You're only looking at 5 to 7 amps of current draw that the one pill is actually going to create. So let's see what we got here for messages. Yeah, that's not as high dollar as some of the others that some of us have, but yeah, definitely serves the purpose. All right, so. camera brought around here. Well, good afternoon, bud man. Get a microphone here, plug it in. All right, so we're going to be doing our testing using our Bench Cobra 29 hooked up to the 2500 watt dummy load. So, we'll turn the power supply on. All right, so we're running this at 14.5. That's our voltmeter for the primary. Of course, you guys can see the computer. All right. I'm going to show you how much drive we're going into. All right, 5 watt slug in reverse, 1000 watt slug in PEP, 500 watt in average. So right now, this is all the drive we're going to be putting into it. Hello, 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 audio. Audio. So very little drive. All right, so, yep, we've already got that in. We're in 1x position. Got the variable turned all the way wide open on the amp. Oh, and this also has, there again, I'm not sure what's going to be done with this. There is an attenuator resistor that's actually involved in this. So this does cut the amplifier down, especially on the PEP. But we're going to leave that in there because I'm not sure what the customer is actually going to be driving this with. So we can get that back into the best view we can for you guys. All right, so variables all the way up. Hello, audio. Let's give it a little drive here. About 100 watt dead key. Hello, audio. Audio. So about 650 on the PEP, but we're getting almost 400 bird, which that's what we're actually after. The HG seem to do more towards the bird meter than they do the PEP. Hello, radio. Radio. So we're still getting about 380 bird out of the amplifier. Let's go ahead. Come on. That warm up here for just a second. Do its thing. All right, so right there we've got approximately 100 watt dead key. Nice and smooth on the variable. Hello, audio. Audio. All right. Sometimes I just wish that the camera was capable of doing a little bit more. All right, so this is where we've got our variable turned back to. Back up here. Wide open again. Audio, audio. All right, so now that we've got a little bit of heat into it, what we want to do is look for our heat spots. Turn this off. Maybe we can get some of that glare off of the screen here. All right, so we're going to go ahead and run down through here. And one of the things that you're going to see, which they're still only about 80 degrees, which is our resistors here on our feedback, which we got 2 watt across there. To the touch, they're still finger cold. Transistors are nice and cold across there. Same thing with our metal clads. We've got here. Matter of fact, they're actually even showing up blue. Same thing with our output resistor. So we know that we don't have an imbalance. Of course, you're going to see a little bit of heat coming off of the 5/8 core transformers. Everything's running nice and cold across there. Same thing with our flyback resistor here, nice and cold. Hello, 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 radio check, 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 audio test, 1 2 1 2, radio test, audio. All right. So everything's running exactly as it's supposed to. So you can take an image of that. Like I said, I know how it looks on the screen versus everything else, but alrighty. So I've been playing with this thing off and on today. Like I said, trying to get it finished up in between Quantus Interruptus. But we've got this one done. Now we're going to go over to a base and actually work on a base too. So that's kind of where we're at right now. Glad you asked. Input reflect. Okay, 5-watt slug in reverse. Going back to the radio here. So the input reflect. Unfortunately, it's hard to get all the meters in there. The camera stand just doesn't have enough movement. Hello, 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 audio. So under a 1/2 watt reflect. Hello, audio. Which that also brings me to another thing, since you'd mentioned that. It's another one of those wonderful little issues that we found. Like I said, it was just all little piddle stuff. But this was another one of those little issues that I've seen. And I've seen this actually quite often. And why, I don't know. I think a lot of it's because of the fact that it's easier to get the input tune to lay down doing it this way. But on the input, okay, you've got your 3 terminals across the input of your rheostat. Okay, well, this is basically nothing more than a variable attenuator is what this is, that we create. Okay, you've got your 5-watt that goes to ground. That's perfectly fine. However, believe it or not, there's actually a proper way to use this. Now, the way I've got this wired up, you've got coming off of your input of your relay going through your RG316 coax. Okay, the way this was originally wired, instead of feeding it onto the wiper, it was actually fed right here off to the one side. And then off of your input, they had it going to the center. And the reason why this is incorrect is because what you're trying to do is you're actually trying not to vary the amplifier, you're trying to vary the input itself in order to go ahead and lower what your carrier is. So by flip-flopping these, a lot of times you can mask one of the major problems, which is on your input. Okay, on the input, there was 2 things that was wrong with the input, one of which they were one turn shy on the input of the 1 pill, and they were using a 270 puff. Okay, so what that wound up giving me whenever I started the whole thing after I rewired this, it gave me about a watt and a quarter reflect on the input. So that was one of the issues that I'd seen. And I think that's the reason why they had reversed those, because whenever you reverse them, no matter what, it actually shows more or shunts more to ground. So it makes it easier to lower that input dead key when you've got a problem. So we went ahead and put the correct value that we needed in here on the input, and then, like I said, wired this the right way so everything's nice and smooth like it should be. So like I said, just a lot of just little itty bitty problems. Like I said, I know this has been through, a couple different repairs. Hopefully, this will be the last repair that it has for a very long time. But alrighty, guys. Well, like I said, I've got this one done. Since I've got another one for the same gentleman, what I'm actually going to do is unhook this, get this stuff out of my way. And while we're still doing the live feed, we're going to go over to another amp. And we'll check out the fan whenever we get ready to actually assemble this evening. We'll check the fan and make sure the fan's actually still functioning, and go from there. As far as if it needs one, we'll put it in there. All right. So, since we're still talking about glitches and problems and current ratings and all that good stuff, I had to run to town a while ago. That's the reason why I stopped. Why? Because I needed a 28-cent part to finish up another repair today. But it's not either one of these. All right, so what we've got here is a Fat Boy 1x4. This one has a 2290 for the driver, so it's not going to need much input going into the main section here. Again, there's a 4.7 ohm resistor that they're using for partial attenuation going into the one pill. Right now, the two major things that I know is wrong is obviously our 5-watt resistor here. That thing is too bad, too smoked. The other thing, and that's what we're going to get into next, we're going to start checking some HFE values and find out how many bad transistors we've got out of this thing. So, got those. Oh, another thing too, it's going to need to be done. There again, going back to some of the issues that I've been seeing. All right, and I've already got this made. That was the main reason why I wanted to see what else I needed before I went to town. All right, I've already got our little Lexan or plexiglass piece made. What this is going to be for, right back here. We've got this huge opening back here behind the power supplies. Now, just like water, air, anything that's liquid, if you will, is always looking for the path of least resistance, including electricity. In this case, it's air. All right. Now, what may or may not have caused some of the issues with this, since we've got this great big opening back here, yeah, we were blowing air over top of the transistors, over the parts and all that. But here's the problem. We've got this great big hole back here. All right. Well, just like the rest of us, what's going to take the, what path are you going to take if you were trying to get out? Well, you're going to take the least resistance. Okay. In this particular case, it's going to be this hole back here. So I've already undone the ground. I've got the cable loose here, and we're actually going to go ahead and cover this up. The reason why is because we want to actually take all the air that's being put into the cabinet, and instead of letting it just run right out the back, we actually want to do something with it which is to force it across the components, down to the bottom, through the heatsink, and out the back. That's actually what we're going to try to do. So how we're going to have to do that is we're going to have to block off that one hole. And in this case, this is what we're going to be using. So I've already went ahead and did a weld here. I did a weld on the inside, then went back and used some high tensile strength hot glue to put that together. So it's got essentially, two ways that's actually bonded. So once we put this in there, we'll take care of that. But that's the easy part. Let's go over here, find out about the transistors, because I've still got these in the order in which I took them out of. Any other questions, guys, so far? Come on, don't make me talk to myself. Polar pop. Get a little more stuff in here to the picture. Yes, actually I do. But on the BBI transformers, whenever I use those, they are by special request. Yep. Yeah, this adds about $12 per 2-pill section. If you want these added into the overall cost, if I quote you an amplifier, if you do not specify, I'm just going to use standard 1/2-inch transformers. Otherwise, these are what you're going to get. Whenever you ask for the upgraded 5/8 core transformers. But this is one of the BBI transformers. Like I said, love these things to death. This is all I would use, guys. But I know everybody's looking for price points. So, like I said, I use these very sparingly. Unless somebody asks specifically for them. I've got a couple of these in my own personal amplifiers that I run, which I do run like a raped 8. But with these, unlike the 1/2-inch, you do have to change the physical wire. From what I've seen, you actually have to go up 1 or 2 sizes on the wire in order to go ahead and make them perform the same. But you can make them perform the same as the 1/2-inch, but they'll handle more heat. The other thing that's nice about these, I can grab these out of the bin. These typically, whenever I've pulled, and I did a test about 3 years ago, as far as on my Facebook page, on these transformers, and I've gotten several different batches over the years, and each time these test typically within 2% of tolerance. They've got an average of about 2% tolerance right out of the box, as far as when you go to match up your transformers. So I've actually quit matching these just because of the fact that the tolerance stays the same. I'll check 1 or 2 out of each batch and then go on, because they have been so very consistent. Yes, on the 14 gauge. That's what I've noticed. I've had the best luck with. It's not too bad. That one's still got a HFE of 20. HFE of 18. Apparently we just got one that's went bad. Apparently they let off the key quick enough on this one. Okay, that was showing 22. Alright, so that brings me to the next thing that I have come across. Alright, theoretically, according to the Atlas, which is just a reference guide, they're all showing good. However, that's where we need to go into the next test. The reason why I say this is because I have ran into this a couple different times too. And when I stopped by the gas station, these were calling my name. So that's what I'm munching on in between here, guys. Usually when your output blows, you don't normally get lucky enough not to have dropped a pill. And I have had the Atlas lie to me before about a good transistor. figured my buddy Rolling Stone would have been out there by now. I was talking to him earlier today, too. Hello, audio. Hello, audio. Alright, so the way I've got this set up right now, I've got about 80 watts. Hello, hello, hello. Hello. Not always the easiest thing to sit there and pull the transistors out of, but it's still much faster than soldering them all in. Hello. Hello. This is my little one pill tester. I can remember back in the days, which this thing's went through a couple of different modifications over the years, but she still works. But I built this many years ago because I had people that wanted to sell me all kinds of used transistors and this and that. I didn't have any way of really checking them. So I sat down and built a one pill, modified it a little bit. Everything's offset. But I did that so that I could actually put a load on the transistors and see whether or not they were any good or not. Hello, audio. 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 Yeah, that one's doing about 70, where the other ones are doing 80. So that one's got the lowest rating out of the 3 so far we've checked. Of course, I have also ran into one of these things just want to fight each other too. Audio. Audio. Hello. Audio. Audio. Okay. Even though that one's got the highest HFE listed according to the Atlas, this one actually is only doing about 70 watts as well. So we've got 2 that's doing 80, 2 that's doing 70. But we know we've got an imbalance somewhere in the amp. Otherwise, this wouldn't work. So again, we've got these 2 that were out of one side, this one, and the one that's in here now was out of the other side. And we've got approximately 10 watts PEP, which is what I'm going off of versus the RMS. But we've got about 10 watts difference in relationship to what this amplifier is putting out. So we've got one of a couple different options, one of which obviously we're going to have to replace this. We're going to have to check our 120s on the transformers. We're also going to have to check our metal clads. In which if there's usually an imbalance, usually it's on the output more so than it is on the input. Rarely have I seen, since these are 500 volt, rated for 500 volts that they've got either on the input, rarely do these go bad, although I have seen them. So that's not good. There's one of our imbalances. That's one side of the resistor apparently let go. There again, this is the side that's low. So we're going to have to check all this, get with the customer, find out which way he wants to go on this, on the resistor, on the transistors. I can try putting them back in there. However, I know that there's an imbalance, and we've got different power ratings coming from each 2-pill section. So we're going to have to find out which way he wants to proceed on that. Gotta love notifications. So once we've checked all that, like I said, we got to find out what's going on, and it may just be the fact that these, although those are all from the same, what I call lot number by HG. I really wish they would go in terms of like the Toshibas, where instead of just putting a little HFE rating, I wish they would actually put a physical lot number down here at the bottom or something, around the outer rim, somewhere, to let us know which batch, which batch these actually came out of. These have got a rating of 64 up in the corner, which is perfectly fine, but I'd like to know which batch these are out of. Are they two separate batches that they just happen to come up with the same numbers on them, so they matched them up and said that's fine, or what? That's it. That's one of the little quirks that I've got with the HGs. I really wish they would get a little more refined for us as far as on explaining what's what on these. Well, hello, Bruce. What's going on, buddy? Yeah, we're just doing a little work here. So we've got two 1x4s. One was a base, one was a mobile. We've already went through the mobile, got it all squared away. Now we've got to go through this base, find out what's going on. We've got a definite imbalance in this that needs to be cured, but we've got to find out what the reasoning behind it is. If it's the transistors, they just don't like each other, which I have ran into that a time or two. Yeah, I could. The problem is I can get this stuff anywhere. It's cheap, and usually I just pick up scraps from the local hardware. So, that's part of the reason why I typically use Lexan most of the time whenever I cover up the holes and take care of that. So, yeah, like I said, I could, but the larger strips like this that are big enough to actually cover the holes, it's a little difficult to actually get a hold of, as far as unless you want to spend some major money. I mean, I've got some boards that I use as far as for custom work, but like I said, this I can pick it up for little or nothing if I go up and I hit them up for their scrap pile, if they haven't already got rid of it, because they just throw their scraps in the trash. So if there's a little 2 or 4 inch piece, which in most cases that's all I need, they just throw it away. Well, I've got little cutters, so why not? Let's go ahead and put this in, get this taken care of, because I've already got everything taken kind of apart on it. Transistors here out of the way. Tighten that back up. Yeah, that is one hell of a glue gun. I will say that. I ordered this, and this is like the berries, guys. If you want low temp, you can turn it down, or you can turn it up to 220 degrees Celsius, depending on what you're actually running. I'm actually running this at about 180 Celsius is what I've had this actually turned up to, which seems to work really well, especially for what we're going to be doing with this. It heats up really quick. But we're going to block off that mega hole that's in the back. Oh, and for those of you that would like to have one of these, believe it or not, the best place that I have found is Fleabag. It also comes with about 5 different tips. I've got the medium length one in there right now, and which works for most everything. But yeah, man, so that is the berries. That is the bee's knees. She's just about ready. Now I've already cleaned up where the pills are going to go back in. But where I've cleaned up the other one and this one, I know my little solder sucker's full. Usually this thing don't stick together, so I must have it really packed. Jeez Pete's. I'll show you the little pile here just out of the 2 amps that I've worked on since I've cleaned this thing. This is just what fell out and what was around the outer edge. There's a 1/4 pound of solder, guys, that I've yanked out of the boards, out of 2 boards. Just about. Yeah, depending on what you want to do with that glue gun, man, you can just about melt anything together. Yeah, I got some of that glue on me the other day and peeled the hide off. My other glue gun that I've got, man, it won't get near that hot. But I know I got some more cleanup work to do with that, so that's the reason why I went ahead and cleaned it out. And that glue is still liquefied. All right, so Sorry, just checking some messages here. I seen my phone was blinking. Yeah, it's easy to burn yourself with hot glue. I'm telling you. All right, so I know that ain't gonna pop out. Let's get this out of the way. We'll get some of these other parts pulled out. And then, like I said, I'll give my customer a call, see which way he wants to go or proceed. Once we replace what we know we have to replace. And go from there. Yeah, the worst thing that sucks about these live feeds is the fact that I can't play music in the background. If we can't remove some duck poop. That's what I was trying to do on this side here a while ago. Alrighty, now let's get some good parts. And I apologize, guys, for not doing any more live feeds here lately than what I have been. And like I said, I have just been super swamped trying to get as much stuff caught up, and it's just one less thing to try to focus on in relationship to the live feeds. I would say whoever had repaired this the last time, the reason why they probably used a 5 watt instead of a 2 or a 3 watt, which now I've been using 3 watt resistors in 90 to 95% of my builds for about the last 8 years. The reason why is theoretically you're not supposed to have more than 1 watt per side as far as in relationship to the imbalance. So with that being the case, when you're dealing with a 2 watt resistor, you split that in half, that gives you 1 watt for each 2 pill, but that gives you no tolerance room. So the 3 watt, that gives you basically a half watt of play or fluctuation. So if you're right at the maximum on one side or the other, the resistor is actually going to hold up. Like I said, since we had a 5 watt that we pulled out that was back here that was burned up, chances are there's a serious fight between these two. So like I said, we're going to have to check the metal clads, we're going to have to check the 120s, that's all going to come out, and check that. While we're at it, we'll probably go ahead and check this, since one side's already loose. Might as well just go ahead and pull this out, replace it too. Alrighty. I'll get all that duck poop out of the way too. Alright. Some extra duck poop out of there as well. We go to resolder those back in. We'll find out what's going on with that. Alright, so wonder if my buddy Herman's ever got in there. Sitting at work. Oh my. Well, hopefully you get an easy night tonight, Bruce. I didn't even see you commented a while ago. Although these things are great, the one thing that they do not do is test under a load. That one's a perfect 1000. Well, that one's not the problem. $998.2. Close enough. That's well within 1% or less. So we're trying to figure out where the imbalance is, and that's the reason why we're having to pull these parts. Okay, all of them are reading 120 except for this one, which it's only reading 119. So one puff isn't going to make that big of a difference. Now, Bruce, if you're still in there, buddy, you know, I was talking to another friend of mine here the other day. He's got a 32 pill, and he's having the same issue that you're having with fans. And ironically enough, that's one of the things that he had made mention that he's actually going to do is go to a blower system on his. because of issues with fans. So on this side here too to hold that in place. It'll all get resoldered again a little later. Let's take care of that issue too, just in case. Last thing we want, Arky and Sparky to have fun. We're going to put little feet on our transformers. Tack back in place. Just to make sure. small bead across the front to make sure that those are all soldered together like they're supposed to be. Because otherwise we'll have a problem there. So now we've got that part taken care of. Insulation back a little bit because we're going to replace this resistor too. And that one's squared away. So it doesn't look like anybody's really monkeyed with most of the input. I know that's what Fat Boy uses on the output, so I know that should be good. Now, once upon a lifetime in this amp, there again, where it's had problems, I know this pill here has went out. There's still a little burnt spot from the tattletale. Alright, so now that we're at the point that we're at, now I need to actually shut this off, call the customer, and find out which way he wants to go on the transistors. I can put the other ones back, but I have a feeling since they're not showing the same as far as on the power, I got a feeling that's where our imbalance is. Like I said, it's either that or and or a combination of that and or standing weight. So when we call the customer, we'll find out which way he wants to go on that, and that way we can get this thing finished up. So guys, I appreciate you taking time to be with me today. We'll get out of here. Like I said, I'll finish this up as soon as I find out from the customer, because I've got the transistors to go ahead and put in here. Speaking of transistors, went ahead and made another order today, under the assumption that this one also needed 4 more transistors, so that pretty much wipes me out. So I had to place another order for transistors today, so they'll be here later this week. But yeah, like I said, we'll find out which way they want to go, try to get this thing back together, and then do a short video either today, or not today, but probably tomorrow on this one. But I would like to get this one done this evening and get started on a Cobra 29 for Mr. Exit 114. All right, guys, I appreciate it. You take care, and we'll catch you on the next go around.